Good morning, everyone. Today I'm going to present the research presentation of strength analysis of improved soil pertinent to shallow ground stabilization, a meta-analysis. This is the content, and I'm going to talk about the introduction of this topic. Soil improvement, literature review, collection of data, selection of data, statistical analysis done in two stages, LMRA and ANN. Results, model performance, and finally the conclusions and recommendations. When it comes to construction industry, it grows very rapidly. Since Sri Lanka is a small country in area, every small area is very important. There are so many abundant lands in Sri Lanka due to weak soil. Due to that, ground improvement is required in order to make use of that land. Therefore, improvement or replacement of soil should be done. Soil improvement can be done in 4 ways. They are without admixtures, with admixtures, using additives, and finally using thermal treatments. As you can see, these are the ways that we can improve soil. From these ways, I'm focused in quarry dust. It is a very cost-effective waste material, and quarry dust is also very commonly used in construction industry also. These are some experiment results that I have got from the literature review. In this research, I'm going to use two statistical tools. They are linear regression analysis and artificial neural network modeling. First, let's go to the linear regression analysis. It is a basic statistical tool. Once the collection of data and selection of input and output parameters are done, then I will perform the linear regression analysis from Microsoft Excel for both output parameters, and then compare the results with the experimental results. Accuracy of this analysis is done using R-square value. There are some limitations to this analysis. One is, as the name says, the analysis is done in linearly, and one output parameter limitations per analysis. Therefore, more advanced analysis should be done. Artificial neural network modeling is a very advanced analysis. Once data sets are collected and selection of input and output parameters, I'll perform the modeling by MATLAB. Then compare the results with experimental results and check the accuracy with the aid of graphs. When it comes to the collection of data, there are many researchers for soil improvement using quarry dust. Those researches are done considering so many parameters like maximum dry density, optimum moisture content, California bearing ratio, coefficient of uniformity, differential free soiling, and Atterberg's limits. I have gone through 11 research papers and have collected 83 datasets. These are the 83 datasets that I have collected. When it comes to selection of data, due to the inconsistency of different parameters in conducted experiments, I have to select input parameters as maximum dry density, optimum moisture content, and quarry dust. And as output parameters, I have selected shear strength parameters such as cohesion and friction angle. These data have been collected from 5 research papers and have gathered 41 data sets. Below, we can see the parameter and the range of input and output parameters. Artificial neural network modeling behavior is very identical to the human brain. Network type that I'm using is feed-forward propagation, and figure shows the ANN network architecture. This includes neurons and they are in layers. First, red box shows the input layer, and second red box shows the hidden layer, and third red box shows the output layer. Figure exactly shows what happened behind the scenes. First, input and output parameters. First, input parameters are split into neurons, and then weights and biases are added. After the output comes, output will compare to the real value and calculate the error. If the error is higher than what we have configured, it will backpropagate and gives more accurate output. This slide shows the mathematical calculation that happened behind the scenes. And to the right, it shows the configuration of the AN network. Linear regression analysis is done using 41 data sets and tested using 10 data sets. We can see the equation for cohesion, and to the right, we can see the predicted cohesion and the actual cohesion value. This graph shows the analysis done at testing and training phase. At testing phase, the R-square value shows 0.8695. The linear regression analysis for friction angle is also done using 41 datasets and tested using 10 datasets. We can see the equation for friction angle, and to the right, we can see the actual friction angle and the predicted friction angle. This graph shows the analysis done at testing and training phase. And at the testing phase, we have the R-square value of 0.9219. When it comes to the artificial neural network, it predicted cohesion value almost similar to the actual value. This graph shows the analysis done at testing and training phase. At testing phase, R-square value shows 0.9841. When it comes to the friction angle also, at testing phase, the R-square value shows 0.985. In this section, I have calculated the residual error of LRA, LMRA, and ANN for cohesion. As I've highlighted from the red circle, the predicted LMRA value is way off compared to the measured value, but the predicted ANN value is almost in line. In here also, I have calculated residual error for friction angle also. As you can see, LRA predicted value is way off when compared to the ANN predicted value is almost in line with the measured value. Until now, we have only compared the R-square values. But beyond that, there are numerous statistical indices such as RMSE, MAPE, EF, and VAF. From these values, it also clearly shows that ANN is way superior than LMRA. There are numerous studies are conducted, but in Sri Lanka, only limited number of researchers are done. Those experimental data can be used to develop statistical models. From this research, it shows that the LMRA failed to identify the complex relationship between input and output parameters, but ANN predicted value is very accurate. Since this model does not need to conduct experiment, it will save plenty of time, and it is very cost effective also. This model is also can be further improved by adding more data and widening the data range and identify more data from literature reviews to predict accurately the parameters. Furthermore, we can use advanced tools such as adaptive neurophysical interference systems, or is known as ANFIS. And these are the references. And thank you.